When the ground tears itself apart, you'd think the safest place would be outside, on solid earth. But during a powerful earthquake, one of the safest places to be might be high up inside a modern skyscraper. These towers can sway several feet and not fall. So how does a building survive the planet trying to shake it to pieces? The secret isn't being strong, it's something stranger. Here's the first surprise. In an earthquake, buildings usually aren't crushed by the ground crumbling beneath them. They're destroyed by their own weight. When the ground lurches sideways, the building's mass wants to stay still. That resistance, called inertia, sends violent forces tearing through the structure side to side. And buildings are built to handle weight pushing down, not shoving sideways. Every building has a natural rhythm, a speed at which it likes to sway. Tall towers sway slowly. Short, stiff buildings sway fast. If the quake's shaking matches a building's rhythm, the sway feeds on itself and grows, bigger and bigger. It's called resonance, and in 1985 it flattened mid-rise buildings across Mexico City, while taller and shorter ones nearby survive. And the ground itself can betray you. A building on solid bedrock is far safer than one on soft, waterlogged soil. Shake wet, sandy ground hard enough, and it can briefly behave like a liquid, a process called liquefaction. Buildings tilt, sink, and topple, even if the structure itself never failed. So engineers study the soil as carefully as the steel. So how do we fight back? The first rule is counterintuitive. A good earthquake building must bend without breaking. Brittle materials like plain concrete or unreinforced brick shatter. But steel, and concrete laced with steel reinforcement, can flex and deform, soaking up the quake's energy instead of snapping. Engineers call this ductility, and it saves lives. To resist that violent sideways push, engineers add stiff shear walls and diagonal steel bracing, giving the building a backbone against the shaking. They also build in redundancy, many overlapping load paths, so that if one beam or column fails, others instantly take the load, and a collapse never spreads. But the cleverest buildings don't just resist the earthquake, they go with it. A flexible frame is allowed to sway, gently flexing back and forth to release the energy instead of fighting it rigidly. Just like with bridges, a little flexibility isn't weakness, it's survival. Then comes the most remarkable trick of all, base isolation. Instead of bolting the building to the ground, engineers set it on giant flexible bearings of rubber and lead. Now, when the earth lurches, the bearings absorb the movement, and the building above barely shifts. The ground dances, the tower stays still. Inside the tallest towers, engineers hang an enormous weight near the top, a tuned mass damper. As the building leans one way, the giant mass swings the other, canceling out the sway. One famous super tall hides a steel sphere weighing hundreds of tons for exactly this, taming the motion from both typhoons and earthquakes. None of this is guesswork. Engineers shake full-scale buildings on giant platforms called shake tables, watching exactly how and where they fail. And every collapse in history rewrites the rules. Engineers design not for an average day, but for the worst one a region might ever see. So the goal was never a building that doesn't move. It's a building that moves intelligently, that bends, sways, and floats, and keeps the people inside safe. So next time the earth shakes, remember, the towers above you aren't fighting the quake, they're dancing with it. Subscribe, and next time we find out how skyscrapers stand up to hurricane-force winds.